Welcome students. Now we'll be studying Poisson distribution. We know what is binomial distribution, what it is. It is NCR, p to the power r, q to the power n minus r. That is the probability of exactly r number of success when we have n number of. So Poisson distribution is the probability of events that are very rare, very rare. For example, number of double deaths on a highway in a year. So that is very rare, maybe 1 or 2 in 365 days. So that is very rare. That is, P is very small. So what Poisson distribution actually is, it is limiting case of binomial distribution where n is the number of events is very large, say infinity, and P, that is the probability of such events, is very low, that is 0. So when we apply this to binomial distribution, we get Poisson distribution. Let's see the formula. Let's derive the formula for Poisson distribution. We have the formulas for binomial. We'll see how Poisson distribution formulas come. In binomial distribution, the probability of R success is this. We know this. This is what? NCR. NCR is n into n minus 1 into n minus 2 to n minus r minus 1. This we know. Then it is p to the power r qr by factorial r. This is the formula. When you must have studied combination, you know NCR means this. So what we do, this is 0, 1, 2 up to r minus 1. So the number of terms is r here. And we have p to the power r. What I'll do, I'll put 1p with every factor. So that this becomes np, then n minus 1, np minus 1. Then it is np minus 2. This is np minus r minus 1 into p. Q is what? Q is 1 minus p to the power, not r, this is n minus r. So this is n minus r. I have written this mistakenly. This is n minus r, okay? And this is factorial r. I told you what we do. In Poisson distribution, n and p have these limiting values. That is, n is very large and p is very low. So that np is a constant. If this is very large and this is very low, we can take it as a constant. Let's say this is m. So what is this now? This is np into np, how many times? R number of times, because this was p to the power r, we distributed p in every factor. So this becomes m to the power r, that is np to the power r by factorial r. So this is this much. What about that? 1 minus p. From here we can write p as m by n, that is 1 by m minus m by n to the power n minus r, or to the power n, and here to the power r. Now this is, if we put the limiting values here, that is limit n tending to infinity, this is e to the power minus m. E to the power minus m, if you expand, you will get this, given n tends to infinity and p tends to 0. So what we finally get? We get m to the power r by factorial r e to the power minus m. So this is the formula for Poisson distribution. That is, the probability of r successes is m to the power r by factorial r e to the power minus m. M to the power r by factorial r e to the power minus m. Therefore, for r equal to 0, this is e to the power minus m. For r equal to 1, it is m e to the power minus m. R equal to 2, it is m square by factorial 2 e to the power minus m. For r, this is m to the power r factorial r e minus m, and so on. So this is the expansion of Poisson distribution, or this is the distribution. So the question is written here. You can see the question. The probability that there is a bad reaction is 0.001, very low, as I told you. It says, what is the probability that more than 2 will get infection? That is more than 2. So this will be for P3 plus P4 plus P5 and so on. Or this probability can be, we would write it like this: x greater than 2. This is also equal to 1 minus P0, that is no bad reaction, P1, that is one bad reaction, and P2, that is two bad reactions. Clear? The question is the probability that more than 2 persons have a reaction, that is probability x greater than 2, that is P3, P4, P5 and so on. This is same as 1 minus P0 plus P1 plus P2. Clear? So what we'll do, we'll find the value of P0, P1 and P2, and then we'll get this value. Therefore P0 is e to the power minus 2, P1 is m square, that is MEM. This is 2 e to the power minus 2 P2. So this is m square, that is 2 square, 4 by 2, that is again this. So what is the value? Let's see. So our Px greater than 2 is 1 minus P0. P0 is 1 by E square plus P1, that is 1 by, no, 1 not 1, 2 by E square, then again 2 by E square. So this is basically 1 minus 1, 1, 1, so this is 5 by E square. This comes to 0.32. So the probability of more than 2 people getting infected, when the probability of infection was this, is 0.32. Clear? Now let's see the constants of Poisson's distribution. We have seen the constants of binomial distribution. I have written them here. These are the values which we have found by binomial distribution. M, that is mean, is NP. Mu2, which is sigma square, variance, is NPQ, and so standard deviation will be under root NPQ. Mu3 is given by NPQ, Q minus P. Mu4 is given by this. Skewness, that is root over beta 1 is 1 minus TP, 2P and this, and B2 is 3 plus something. So you know these constants. When you have studied binomial distribution and the constants of binomial distributions, you know this. What is Poisson distribution? I told you in the start, it is the limiting case for n tending to infinity, p tending to 0, and therefore consequential is q tending to 1. We will apply to this. Poisson's distribution, we get m is equal to np, same. Mu2, that is npq. Clear? This is sigma square. So mu2, that is sigma square, here what it will be? Q is almost 1, so this will be equal to np, so this is m. Therefore standard deviation is root over m. Clear? Now mu3, this is q minus p, so p is almost 0 and q is almost 1, so this will be npq, again q is almost 1, so this will be np, that is m. So mu3 is m. Now mu4, see, we multiply this is m plus 3 into pq into pq, see this term, npq, It is almost NPQ into NPQ, that is a square, which is M square.
So finally what we get is that mu4 is equal to M plus 3M square. Now we have skewness, that is root over beta 1. In the denominator we have root over NPQ, that is root over M. Now P is very small, so this will be 1 by root M, but since it is very small, what we do, skewness equal to root over beta 1, that is equal to gamma 1. We denote it as gamma 1. We say it is equal to 1 by M. Now kurtosis beta 2, it is 3 plus 1 minus 6 PQ by NPQ. So putting the limiting values, what we get is gamma 2 equal to beta 2 minus 3, that is equal to beta 2 is equal to 3 plus 1 minus 6 PQ. PQ is what? It will be 0 because P is very small. Therefore, this is 3 plus 1 by M. So, beta 2 is equal to 3 plus M. So, what we finally get is, these are the binomial constants and these are Poisson distribution constants. Okay.
So let's see our first example. The question is that a random variable has a Poisson distribution such that P1 is equal to P2. And what we are asked, we have to find out what is the mean and what is P4. How can we find? Very simple. P1 is what? M to the power, the formula is M to the power R by factorial R e to the power minus M. So what we know, this is R is 1. So M to the power 1 by factorial 1 into e to the power minus M. This is P1 is equal to P2. What is P2? M square by factorial 2, that is 2 e to the power minus M. So this cancels, M cancels this implies M is equal to 2. So from this we get M is equal to 2. The first part is clear. Then we have to find P4. What is P4? M to the power 4 by factorial 4 e to the power minus M. M is 2. 2 to the power 4. That is 2 by factorial 4. 1, 2, 3, 4. E to the power minus 2. 1 to cancel, 2 to cancel. So this is 2 by 3 e to the power minus 2. Clear? This comes to 0.9022. Sorry, not 0.09022. Okay? Our second problem is, it says P2 is equal to 2 by 3 of P1 and we have to find P0, P3 and we have to find Px greater than 3. These are the three things that we have to find. Let's see. What is P2? This is M square by factorial 2 e to the power minus M is equal to 2 by 3. This is M e to the power minus M. So this cancels this cancels this. Okay. Then what is M? M is equal to 2 into 2, 4 by 3. So from here we get the value of M. So M is equal to 4 by 3. So what is P0? P0 is e to the power minus M. That is e to the power minus 4 by 3. What is P3? This is M, that is 4 by 3 to the power 3 into factorial 3. Clear? M to the power R by factorial R e to the power minus M. This is equal to 4 cross 4 cross 4 by 3 cube into 2 into 3. So 2, this is 16 into 2, 16 into 32 by 27 into 3, 81 e to the power minus 4 by 3. Okay. Finally, it says find P3. What is P3? Px greater than 3. So this will be, it is greater than 3, not equal, greater than equal to 3. So this will be equal to what we want to know. Greater than 3 means P4, P5, P6 and so on. This means 1 minus P0 plus P1 plus P2 plus P3. You know how to get P0, P1, we have found these values. You can put the data there and find answer. Clear?
Okay, so let's see another example. The question is, prove that m into mu2 into gamma 1 into gamma 2 is equal to 1. This is, we have to prove. Let's see how. M, M2, gamma 1, gamma 2. Let's see what is M, mu2, gamma 1, gamma 2. M is M. Mu2 we have seen is equal to M. Gamma 1 is 1 by M and gamma 2 is again 1 by M. How? Beta 2 is equal to 3 plus 1 by M and gamma 2 is beta 2 minus 3. So it is 1 by M. So if you multiply them all, you get 1. So simple. Okay.